Hi everyone. So today I'll be discussing chapter 4, the theories of conditioning. And in this presentation, I'll be looking at the first section, which is the Rescorla-Wagner model. And so this model assumes that learning occurs on a conditioning trial only if the unconditioned stimulus, or the US, is surprising. And this has to do with the blocking and unblocking effects. And so signals make the unconditioned stimulus predictable and unsurprising, and there's an element of surprise when learning does occur. So initially, there's nothing to signal that the unconditioned stimulus is going to occur, and so the subject is surprised, and this surprise is what causes learning to occur. However, over time, the subject comes to expect the unconditioned stimulus, and so once this occurs and they expect it, no more learning will occur. It has already happened. And so there is an upper limit to learning, and it's reached when the unconditioned stimulus is no longer surprising. So associative strength is usually abbreviated V, and it's a predictive value, and V increases until the conditioned stimulus predicts the unconditioned stimulus perfectly. And this can be visualized on a graph with an asymptote or an upper limit, and this is usually signified as lambda, which is a Greek symbol. And so as you can see here, there is an equation for associative strength. And then you can define which each symbol in the equation means. So delta means the change in associative strength, and the alpha and beta are fractions that relate to the conditioned stimulus and the unconditioned stimulus. And then the lambda minus the V, or associative strength, is the surprisingness of the unconditioned stimulus. And when you put this all together in the equation, it predicts the associative strength. However, there can be prediction error, and the size of error between the US and the conditioned stimulus is predicted. And this is kind of hard to visualize, especially because it's a math equation. But there were two figures in the book that I found helpful. It was figure 4.2a and 4.2b. I would definitely recommend looking at those. And so overall, this model describes the learning curve. So if two conditioned stimuli are present, they both contribute to predicting the unconditioned stimulus. And this is described by the sum of all of the V, or as I said, V is associative strength. So it's described as the sum of associative strength values of all stimuli present for a given trial. So blocking and unblocking. So the blocking experiment occurred when a noise and the unconditioned stimulus were paired together. And so this light noise compound was paired, and then the same unconditioned stimulus was also used. So basically it went from being a noise and an unconditioned stimulus to a noise, the unconditioned stimulus, and light was added when the noise occurred. And so in the end, it was concluded that no learning occurred in response to the light because it had no associative strength. So all the learning had occurred in the beginning when the noise signaled the unconditioned stimulus. So extinction and inhibition. So the model provides information about extinction, and it predicts that associative strength will decrease on the extinction trial until it reaches 0. This can be seen in figure 4.3. I also thought that was a good one just to kind of clarify. And the animal adjusts its expectation. So Pavlov's experiment also kind of occurred in this context because the animal, or the dog, came to expect that the bell would mean that food was going to be presented to it. And so excitation and inhibition are on opposite ends of one continuum. So if you think of that kind of as like, say like a number line, they're on opposite ends. And so the performance to a compound stimulus will be the summed value of the compounded conditional stimulus. And then that's in terms of the model, which this refers back to the original equation. And it provides protection from extinction. So the main point is that if you want extinction trials to be truly effective, put your conditioned stimulus in compound with other exciters. So there were other new predictions, which also occurred during the light and noise experiment. I didn't go into great detail in this presentation about them, but it had to do with the over-expectation effect. And again, there are figures in the book that kind of show you visually exactly what these predictions are, and I found those to be helpful, so I did include them in here. So there's the conditioned stimulus and unconditioned stimulus contingencies, and it clarified the connection between them. And so the conditioned stimulus and the unconditioned stimulus always occur together with additional stimuli in the background. These additional stimuli are also known as contextual stimuli, and they serve as a single long-lasting conditional stimulus. So the negative contingency situation had two types of trials, one where the conditioned stimulus was presented, and trials during the intervals between conditioned stimuli when the context is presented alone. So these two types of trials were definitely beneficial in learning more about negative contingency. And so in the negative contingency case, the conditioned stimulus context compound is not paired with the unconditioned stimulus, but the context is paired with the unconditioned stimulus on its own. And then the zero contingency case has two types of trials that propose the contingency effects results from conditioning of the context, and the subjects learn that the conditioned stimuli and the unconditioned stimuli are associated, and that the context and the unconditioned stimulus are also associated. So I know that's kind of like a lot of information. It can be a little bit confusing. So kind of what does it all mean? So the model provides a very successful account of compound conditioning, and this model is still focused on the idea of learning. And general points to take away are that conditioning always involves compound stimuli, and that the increment or decrement in conditioning to any individual element depends importantly on what the other elements of the compound predict. So I would definitely recommend going and looking at some of those figures in the book. I found them to be very helpful. And if you can understand what this first section of the chapter is talking about, it'll definitely make it easier to understand the rest of the chapter. So good luck.